I guess. What are derivatives and why are they useful? They help you start awesome conversations at the school disco. Apart from that, graphing. They help you get good marks in maths.
Derive or something?
Just say the word. Just read it.
Oh, they make you look like you know what you're talking about.
Derivatives sounds fine.
Okay. So, what's a tangent? Let's start with that.
Draw it on the graph.
You draw it on a graph. Ready? So I'm tangent. Ah, there we go. Okay. So what's a tangent?
And then draw it on 1 point. Intersect.
So if I wanted the tangent at this point here, what would I do?
Just draw a line
Like that? Okay. And the line must go as close as possible to the function without actually cutting it. Correct? Could anyone tell me how to find a tangent? The equation for the tangent. What's going to happen to the tangent as we go through this function?
Go down the line straight.
It's going to get steeper or less steep?
Less steep. Less steep.
I'm hearing different things. As I go that way, is it going to be steeper or less steep?
As it goes down, it'll get less steep.
Yep, as it progresses that way, will the line get steeper or less steep? Steeper. It's obviously going to be a negative gradient though, correct? So, we use derivatives to find what we call a rate of change. And I've given you a physics example here. It's good of me. Okay. But we can create an equation for the rate of change. So at any point in time x, so I could find my rate of change or my tangent at a point 1.5 seconds or 1.5x along the axis. So how do I find the derivative for this function? First of all, how do we represent the derivative?
X.
I write y equals. So if I've got y equals negative 4.9 x squared plus 60, I'm done, right? That's derivative found. What's my next line of working?
Y equals.
You change it to
X. When x equals 1.5, y equals.
Well, okay, so let x equal 1.5.
Well, I actually don't know.
Is that going to tell me that gradient of that line?
Yeah.
We'll find x because x is the gradient. Just like a line.
There's
Yeah, because it looks like
you bring up gradient, but gradient's very important. Gradient's an example. Gradient's a tangent on a linear function. So if you think about that, if you've got a line, the gradient is rise over run, but that is just the tangent of that line.
So we're finding.
So it's a rate of change. It is a rate of change. Gradient is an example of a rate of change. How do we write gradient? Let's start with that. Rise and run. What rise and run mean? Change in x. So we write change in y over change in x, correct? Okay, let's not go y2 minus y1. It is correct, but I'm trying to link this into derivatives. I'm going to replace that little triangle, which means change in, with d. dy dx. I know you've done this. Okay. Now, and I remember a rule. I'm going to give you a function, and what do we think the derivative of that is, first of all? Does anyone know what the derivative of that function is?
You give me my book from last year.
Does anyone know? Okay, what type of function is this? The blue line. So it should be in the form where x is the pair of 1, correct?
Yeah.
Where did you get negative 9.8 from?
That's it squared.
No.
4.9 times 4.9 would be 9.8. Is it?
Yeah.
Cancel it out, it's a 4.9.
These were the inverse.
Y equals ax, let's just make a general form. Y equals a x to the n. Can someone see a pattern for how I got that?
A is the value.
Yep, so a is the negative 4.9.
4.9 times 2.
So I went, well, n was 2 before, wasn't it?
Yeah.
So it's n a. What happened to the x? Is x still there? X to the what? X to the 1, but it was to the 2. So how do I make a general rule for that?
And say. No.
Oh, what if it's like
It's always in type 1.
3?
Well, let's have a look. So y equals, give me a function. Polynomial. Someone say some numbers. 6x cubed plus 24 what? Give me an x value.
2.
X to the 2. Okay, plus 6.
Well, that's
dy dx. To go through that. Have a go.
Adding the powers and all.
Have a go. Just have a go. Jet's got it. So what do we think the first term's going to be? What am I going to write first?
collect like terms.
No, I don't want to collect like terms. Just want to. What's the first thing I'm writing?
3.
18.
18.
X squared plus 48.
Oh, no, you drop one. You add it. You drop one. Oh, and then G, yeah.
Well, that's a great point.
You should go through it.
Plus, is it totally just top?
The 6
You got rid of the 6.
drops. And
Is it plus 5?
No, you got 0. So you got rid of the 6 and 13.
well, I'll show you this one. Let's have a look.